to waves. Let's talk about that. Waves, there are two types of waves. Before I go on, actually, does anyone have any questions regarding that? I can talk about electromagnetism and X-rays in a bit, so don't worry about that too much. Yes. Which ones are X-rays made of? Gamma rays. X-rays are made a form of electromagnetic radiation, so it's gamma rays. I think that's it. Okay. Okay, cool. So, waves. There are two types of waves: transverse waves and longitudinal waves. Transverse waves, they are caused by vibrations that are perpendicular to the energy transfer. Perpendicular, that's an important part. If it is longitudinal, the vibrations caused by the longitudinal waves caused by the vibrations, they are parallel to the direction of the energy transfers. So please be careful when you're answering the questions, when you're comparing the two. Transverse is perpendicular to the energy transfer, longitudinal, parallel. It's also quite easy to differentiate the two based on their structure, as you can see on the top right. The transverse wave just looks like what you would typically think what a wave looks like. A longitudinal wave, you're going to have compressions and rarefactions. So the rarefaction is going to be the ones that are more loosely separated. Compressions are going to be the one that's closer together. Examples of transverse waves would usually be light or water ripples. Examples of longitudinal waves would be sound. That is the most classic example. Properties of the waves, you can see here, there's wavelength, there's the peak and the trough, the amplitude. That graph already tells you kind of what you need to know. The main part I want to emphasize on here is knowing the units of this. So you need to know amplitude. That's the height of the wave. You need to know the wavelength is the distance between two equivalent points. And you need to know the frequency is the number of waves produced per second, or the number of waves that pass a point in a second. A period, this is a math question that shows up a lot. A period is the time it takes to produce one wave. And because we know frequency is the number of waves in 1 second, you can use the equation period equals to 1 over frequency. Remember the units. Period is in seconds and frequency is in hertz. Always, always in frequency in hertz. Frequency is always in hertz, not kilohertz. Period is always in seconds. Remember to note that down. Oh, okay. With all of that, this is a bit, I think some of this might be only in triple, but generally this is all covered in both. The wave speed, there's also math again, calculated by frequency times wavelength. It is in meters per second, nothing else. Be careful with the unit, as I've said. There are other ways you can figure out the wave speeds. You can use a water ripple experiment. You can also figure that out by looking at an oscilloscope. A really interesting one is that by figuring out the sound waves, you can actually see how long it takes an echo to go from one side of the building to back to you. That's a way to figure out wave speeds. Those are just a few examples you can look at. Transmission is something I do want to look at because it's a little bit more theory-based. So, transmission. Waves can travel from one medium to another. However, from going from, for example, air to water is not as simple as just the wave just goes through. Even though the frequency doesn't change, the wavelength will increase or decrease depending on which medium it goes to. And because we know the equation, wave speed equals frequency times wavelength, the wave speed is also going to increase or decrease depending on the wavelength. So if there's an increase in wavelength, because frequency doesn't change, wave speed's also going to increase. If the wavelength decreases, the wave speed's also going to decrease when you're traveling through a different medium. So for example, the wavelength and speed is going to decrease when they go to shallower water compared to deep water. Deep water going to shallower water is a different medium. Different medium, decrease in wavelength, therefore decrease in speed. Also something to point out, this is triple science. Sound waves is triple science. Sound waves will travel at different speed in different mediums. So this is something to point out. This is also only in triple. This is something to know. Triple sciences, they love to ask you about the different spectrums. You need to know, not the specific numbers. I don't think you need to know the numbers specifically on what each of them are, but you kind of need to know the region. So radio waves is going to be the smallest, like not smallest, but like the largest wavelength. How to explain this? That's not a good way to explain it. but it's going to start with radio waves, and then it's going to be microwaves, infrared, visible light, UV light, X-rays, gamma rays. So when I said X-rays are kind of like gamma rays, it's like it is technically partly gamma radiation, but gamma rays is like higher compared to X-rays. So that's something to note. It's gonna go increasing in frequency. Those are gonna have a higher frequency as you go up. So gamma rays have a really, really high frequency, but they have a very, very small wavelength. You need to know you need to know the orders, and you kind of need to know not the specific numbers too much, but you need to know kind of the positions. So this is like a good picture to show you the positions of that.